Alright, so for this next part, and how to make your own numpad, we're going to be making the PCB. So I did this with KiCad, and I had never used KiCad before, so it took me a little bit to learn how to use it as I was going, but overall I think it's a really good piece of software, and ended up being pretty straightforward to use. So I'm going to go ahead and use that for the tutorial. And I've already got KiCad open here. I just went with the assumption that you all watching could install it yourselves. Obviously the installation process was going to be a little different depending on what platform you were on, so I just thought I'd avoid all of that and just skip to using it. So here we've got a project that I just opened or started, and if you want to know how to make a project, it's just file new project. You're gonna navigate to where you want to save it and just give it a name. So I've named mine 17 keys because I'm unoriginal and that's how many keys there are in a numpad. But you got these two files when you start out. It's basically the schematic file and the PCB file. So we're gonna start with the schematic. And this is basically just our blank work area where we're going to basically set up how all of our components are electrically connected. It has nothing to do with where they'll physically be on the board, it's just making the electrical connections. So the first thing we need to do is actually add some libraries for these extra keyboard components. So you're going to go to Preferences and Manage Symbol Libraries, and then go over to Project Specific Libraries and add an existing library. So this defaults to just trying to find folders or library files in your project folder. Now obviously we don't have anything there yet because we just made the project. So there's basically two libraries that we need to download. I've already downloaded them from when I did this myself, so I'm just going to grab them, but I will link them below in the description. So you basically get all these, and we're going to put them in our project folder. Just a quick explanation. These .pretty folders are for footprints, which are basically like how the component will actually physically be on the PCB, while the libraries are just electrical components that don't really have like a shape or anything. They're just the function of that component. So we can go ahead and close that. And now, since we're in the schematic, we just want to add the libraries, not the footprints. So we're going to add each of those. And we can go ahead and hit OK. And then we're going to come over here where it says Place Symbol. And we can just click anywhere. It's going to load all the symbols that we can potentially place. For the switches, it's just this key switch under keyboard parts. So we can go ahead and place that somewhere. And then another thing that we're going to need is D, which is just a diode. So we can put that somewhere. And then the last thing we need is just the microcontroller. So because we added that Pro Micro library, we now have the ability to drop in this Pro Micro. Now we can zoom in by scrolling. We can start doing some real work here. So the way that a keyboard matrix works, without getting into it too much, is that there's a pin for every row and column in your keyboard. And the microcontroller cycles between sending voltage out over each of the rows. It just like loops through sending voltage out to just one row at a time. And then, because closing the switch completes the circuit, you're able to see on that row which columns were pressed, or just which keys on that row were pressed. So with that concept in mind, we need to designate some rows and columns for our keyboard. And since there are 20 keys, the most logical thing to do would be to have 5 rows and 4 columns. So I kind of already know like which keys are going to be, or which pins are going to be best for this. But if you're following along like instruction for instruction, you can just copy me. Otherwise, you should look up what pins you can use for building a keyboard with a Pro Micro. Now I'm just going to bring up a picture for myself real quick of the schematic I made originally. So I can zoom in here. Wow, the PDF viewer in Microsoft Edge is terrible. 1 second. Gonna go ahead and open that with Chrome. Okay. So, what I originally did when making this was I made C6 column 3. So the way we can do that, you can just connect all of the columns to the pins with wires, but you can also give them these flags so that the schematic knows that there is a connection there, even though there isn't like a wire actually drawn. It just helps simplify things a little bit. So we're going to go ahead and connect that to C6. I made D7 column 2. I made E6 column 1. I made F7 column 0. And then for the rows, I made B6 row 4. I made B2 row 3. I made B3 row, or sorry, B3 row 2. I made B1 row 1. And I made F4 row 0. Let me just check that over real quick. And yeah, that looks right. So the cool thing is, now that we've made those flags, is we can essentially just put other flags over here. So let's say this is where we want column 0 to be. We can do that. We can start to draw. Whoops. That's not what I wanted. I think I just do that. Yep. Oh man. Alright, let me just move this first. It's kind of flubbing that up a little bit. Alright. Now, can make our connection. So okay, now we have column 0 connected to one side of this switch. And the other thing that we need to do is have a diode on the other side of the switch. So we're gonna change this to this orientation and then just move it up here. We can connect that with a wire, and now we can go ahead and make the flag for row 0. And then we can connect that. So this is basically what we have to do for every switch now. So just to give an example of how you would continue adding to this, is we'd go ahead and place another key switch, and we can put it like here, and then we can place a flag for column 0. And now we can connect that with a wire to the switch. We can copy this. Actually, let's get rid of this switch, and we can just copy this whole thing. Okay. And then we just connect these wires. So that's like how a 2-key keyboard would work, essentially. The other thing we have to do is name all these. So, let's go back to using the mouse. We're gonna name this. So on the numpad, this would be numlock. So I'm just gonna call it like k_numlock. We're gonna do that with the diode as well. Okay. And then let's see, what would the next one be? Equals, I think. I don't know. If this isn't right, it's whatever, you get the idea. So that's how you'd have to name it, so that you can actually reference the specific switches and diodes when you go to make the PCB later. So yeah, this is pretty simple so far, but I'm not going to go do this for all 17 keys right now. So what I'm going to do is save this and close out of KiCad for a second. And I'm just going to copy the schematic in from the one I already completely finished. So that's going to be this file. And then I'm going to go back to the one I'm working on for you all. And I'm just going to replace that. And now if we go back to KiCad and we open the schematic, we'll see what we had for the full keyboard. So Yeah, it's pretty much what I showed you all, but there's just more switches. It's important to note that for these like 2U keys for addition, the enter key and the 0 key, you could put them like here instead of here, or here instead of here, or here instead of here. But it will matter when you go to make the firmware later. So you can choose whatever you want now. You just have to keep it in mind, or be able to just reference this file again later. So now that we have the schematic fully done, we are going to start making the PCB. So the first thing we have to do is click on this associate file. And this is how you tell the PCB editor what footprints to assign to every component in the schematic. But before we start associating, we need to add footprint libraries again. So we're going to go in, and we're going to go to our keyboard parts pretty. Now, we don't want to use global libraries, I know that. Huh. Let me go make sure those actually copied real quick. Whoops. Yep, .keycat_mod. I'm just gonna restart KeyCAD real quick, like completely, because I did paste those in while it was open. I'm not sure if that's why they're not coming up. It's taking a unusually long time. Alright, let's try that again. Okay. Ah, okay, you just add the folder. So that's why it wasn't working. So that should be all we need. And then for all of these components, we need to say what to associate them with. Now, because I copied this, they're already associated. but I will show you how to do that. So for the diodes, for example, you would go over on this side to keyboard parts, and then you would pick the keyboard parts D underscore S0 D123 underscore axial. So you do that, and you can just go through and do that for every single diode. Just keep double clicking. Okay. Alright, that's all the diodes. Now for the switches, it's pretty similar, but we're actually not going to use any out of the keyboard library. We're going to use this built-in button switch library. And the first one that I go to is button switch keyboard switch cherry MX 1.0 plate. And oh, okay, I didn't mean to hit OK there. Okay, so yeah, 1.0 plate, and I just go through all of these first and set them to 1.0 plate because it's just easy to do it that way. And then I go back and I set the ones that I know aren't a one-use switch. So 0 I know is double wide, and then enter is double wide but vertical, and add is double wide vertical. Now for all of these, you can do the PCB variant. The difference is that the PCB variant just has 2 extra holes that it makes in the PCB. It's probably better to use the PCB variant because it allows those any switches that have those extra 2 legs to fit in. But it does cost slightly more to get the PCB fabbed then, so I just didn't do it. But yeah, like I'd say for overall compatibility, you'd want to do the PCB version of all of these. And then for Pro Micro, we're gonna go find the Pro Micro library, and then just set it to the only option, Pro Micro. So after all of that, we're gonna do apply, save schematic, and continue. And now we can generate the net list. And it's going to ask you where you want to save this file, so the default is fine. And that's all we have to do on the schematic side. So we can save the schematic now, which it already is, and we can close it. And open the PCB. Whoops, I didn't want to maximize that. Alright. Now we're going to have a blank PCB, which seems, you know, kind of annoying. We just went all through that. We went through all that work making the schematic. Now I got to do it again for the PCB. But no. All we have to do is import what we already made. But before I do that, I'm going to change the grid size to, whoops. It is, so the width of a 1U key on a keyboard is 19.05 millimeters. And the smallest amount that we ever need to increment by is 1/8 of that. So if we do 19.05 divided by 8, you're going to get this number, which you can put in, which is 2.38125. And you can put that for X and Y. And that's so that when we're moving the footprints for the switches around, they actually snap to the right places, which is super helpful. So, yep, that looks good. And then once we've edited the user grid, then we're just going to set it to that. But actually, that doesn't seem right. Ah, whoops. Okay, I edited the origin by accident instead of the increment. So we do want to keep this 0. Okay, there we go. Alright, so now that we've made that one quick change, we click on this netlist button and we click first we open the netlist file, and then we do, I believe, update PCB. Yep. And we close that, and now we've just got all these parts just scattered around. This looks pretty annoying with all the connections. That's what these white diagonal lines are. So those are called the the rat's nest. So we're just going to go over to items on this layer manager and uncheck rat's nest, which hasn't updated it for some reason. Huh. I haven't run into that bug before. I'm going to just save this and close KeyCAD again, because that should have toggled them off. Oops. Okay, so yeah, now they're turned off. But obviously this is not at all how our keyboard is supposed to look. So this begins the kind of annoying part of making the PCB, which is the fact that we gotta move all this stuff around. So what I generally do is just get the microcontroller and all of these diodes out of the way. Like that. And then we can start putting these keys in the right spot. So first one I want is numlock. So I'm just going to move that up into the top left-ish area. And then we want divide. I don't know why these are not centered. Okay, there we go. Whoops. Okay, and then we want multiply. That looks good. Then we want subtract. Okay. Can probably just set up the left side now. Whoops. get all the vertical keys in there because it's easy to find them. Then we can put the period in, the 0 in, and then the rest of this becomes very straightforward if we know how to count. So 7, 8, 9, 4, 5, 6. We got our 2, got our 1, and we got our 3. So nice. We've got all the keys laid out now. I'm just going to move this stuff over here so that it's easier to access. And actually I'm going to move all of this down because we do want to put the microcontroller up top. And now I'm just going to move all the diodes into place. And I typically put them just at the top. Oh, sorry, that was dot, right? Yeah. I put them on the top edge of the switch that they're corresponding to. So for enter, can put that here. For multiply, can put that here. Let's see, numlock, subtract, D1. Oops. D2. D3. D4. Is this the 5? It's hard to see. Yep. Here's the 6. I'll grab the 9 while we're at it. What's this, 8? Yeah. Seven. Here's D0. Grab this one for addition, and then the divide one I'm actually going to leave alone for a second, which I will explain. But I need to figure out where the edge of this board is going to be. So generally how I do it is I make an extra little border around here like this, just of 1U, or sorry, 1/8 U. So it looks something like that. So that means the very top of the board is going, actually, let me rotate this first, so, oh wait, oh, I forgot to put these on the bottom. Okay, I need to flip all these over. Sorry for everyone following along. But, so right now all these footprints are on the same side of the PCB, and that actually is not going to help. So we need to flip all of these. Okay. Now we can go through the effort of moving these all back. So this is the period. Oh boy. Zoom's a little wonky right now. Alright, so it'd be something like that. Where's the 0? Here's enter. Add. Subtract. Multiply. Numlock. D7. D8. I'm gonna leave divide alone like I was saying. D9. Okay, D1. D2. D4. D6. And D5. Now what I was saying is that I gotta kind of imagine where the edge of the PCB is going to be for a second. So I want to rotate this because this is gonna go something like that. And then we can see. So there would be 1, 2, so a quarter U for the gap. And then there would be another 1, 2, 3, 4, 5, 6, 7, 8 for the 1 U above it, and then the 1 U border. So the edge of the board is this line right here. So we can move this up actually to something like that. Let me just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, that looks good to me. And now that that's there, you see that there's a problem, which is that the microcontroller is going to go right where I would normally put the diode. And while you could maybe get it where the diode is just under the microcontroller, it's probably not going to be easy or look good. So that's why what I do is I just rotate this and put it like here, I believe, is where I put it. So something like that. And now we have all of our components put in the right spot. So I'm going to go ahead and save. And then I'm going to see what else we got to do next. I want to make sure I'm getting all the steps right. Okay. So now what we want to do is make the edge cuts. So we're going to go to this layer tab on the right and click edge cuts, which just says what layer we're going to draw on. And then I think we just use this. And we zoom in so we can see the edge. Yep, and we just draw these edge cuts. Nice. Pretty easy. And now we need to make a ground plane. So we're going to use this zone tool right here. We're going to make sure we're back on the front copper layer. And we're just going to click on one of the corners of this edge cut. And this is going to come up. Whoops. And we're just going to find the G&D net. Hit OK. And then we do the same thing where we just need to trace all this basically. Now it's going to look really weird for a second, but it's normal if it looks all red like this. And now we're just going to switch to the back copper layer. And do the same thing. So now it looks like that. And we're just going to go over here and switch this to this so that it's, oh, actually to this. So it's not so weird to look at. But yeah, you should have just this little red and green cross border now. I'm going to go ahead and save again real quick. All right. And let's see. All we basically have to do now is route all of our traces. So before we do that, we're going to change the grid back from the user grid to just something a little more normal, like 0.1 inches. So let's turn the rat's nest back on so we can actually see what traces we need to kind of like account for. But to draw the trace, we just start drawing. Oh, whoops, I'm still on ground plane. So it's this. I can just click here and make that connection. And now the one rat's nest for that goes away because the connection is made now. We can do the same thing up here. And you basically just keep doing that for all of the connections that you need to make. I'm not going to go through and show every connection because I've already done it before, and this is probably one of the most time-consuming parts. So I'm going to save this again and just open the final version that I made when I originally did this. Which is right here. So you can see if I go to items and I turn on the rat's nest, there are no white lines because I've made all the connections. Some of them are red, meaning they're on the front. Some of them are green, meaning they're on the back. But it's nothing different than what I was just showing you. Now, to make sure that everything works, you basically just need to check that the connections on the PCB match the connections on the schematic. And there's a built-in tool to do that, which is this DRC button right here. So you click on that, and you do run DRC, and you do list unconnected. If there are no unconnected items here, then you're good. If you want to see what your PCB is going to look like, there's a built-in 3D viewer. So you can kind of just like move this around and make sure everything looks how you want it to look. And now all we have to do is generate a Gerber file so that we can upload this to a site like JLC PCB, which is what I used, and they can actually manufacture it. So to do that, we need to click on the plot icon, which is this one right here. And then we're just going to say that this is in the Gerber directory inside of our project folder. And then you want to make sure that the front copper, front paste, back paste, front silk, back silk, front mask, back mask, and edge cuts layers are selected, which are the default layers. And then you want to make sure that this use protel file name extensions option is checked. From there, we just click plot, and then we click on generate drill files. The main things are just to make sure that this is in inches for drill units. This is PostScript for map file format, and that mirror y-axis is turned off. And then we just generate the drill file. Now we can close all this out. I'm not going to save changes because I already finished this before, but if this was you doing it, then you should just save here as well. And I'm going to go back to now the original version. And now we have this Gerber folder. All you do is you just grab all of these and compress them. So for me, I just called it 17keys.zip, but you can see that it just has all those files in here. And now we can go get it manufactured. So I use JLC PCB because it's been the cheapest for me, but you can check out other sites to see if you can find something for cheaper. But basically just go get a quote. You add your Gerber file. it seems JLC PCB's site is a little busy. But basically, if I can't get this to work at the moment, you just upload your Gerber file here. There's some settings that you can choose, like what kind of finish you want, what color you want, how many you want. You can choose to have them not add additional marking to the silk screen, which I always recommend. So that's exactly how you designed it. And then you just order it. And yeah, it looks like it's not going to load right now, which is unfortunate. But yeah, once you have that Gerber file, you're basically just one step away from actually having the physical PCB. And that's just sending it to this site and ordering it. And that's it. So now in part 3, I'll show you guys the last step, which is making your own firmware to actually flash onto the microcontroller. So it operates as a keyboard and not just as, you know, a paperweight. Alright, see you guys then.